So we are live now. The recording has started. Welcome everybody again to our session, to our first webinar, to our first content webinar of the Elements of AI Luxembourg 2025 edition. We have been very happy to see all your engagement with us during the last week and after the last introduction session. And we are very much looking forward to delve into the topic of today, which is presented by our host, Dr. Najjar. Dr. Najjar has been a postdoc researcher before joining LIST. So he was at the AI RoboLab and the ICR team headed by a professor of the Luxembourg University, Professor Leon van der Torre. And he worked, prior to joining the University of Luxembourg, he worked as a postdoctoral researcher in the Hubert Curien laboratory at the Jean Monnet University, Saint-Étienne in France. His main research topics were vehicle personal assistant agent, multi-agent negotiation, user-centric systems, and quality of experience. He obtained his PhD in computer science from the École des Mines de Saint-Étienne, France. His thesis was supervised by Professor Olivier Boissier, and at the moment he is working at the LIST as a senior researcher in research and development, and he is in the team of Trustworthy AI. So, Dr. Najjar, Amro, maybe you can add a few things. Welcome to the session.
Many thanks. So, thanks. First, let me apologize for any delays because of the technical issues. Second, thanks for the introduction. Many thanks for Sana, who is not here with us today, for the preparation. What I want to add is I work in LIST, as you mentioned. So what we are interested in LIST is more an interdisciplinary, cross-disciplinary approach between different disciplines of science and also industry and society. So I'm happy to be here. I think this is a cross-disciplinary program by excellence. So I'm happy also to answer the questions from this perspective. Yes, I shared the slides. I don't know if you have them, if you have received them or not. I think it's because it's 40K, so 40 kilobytes. I send it to both of you.
Mm-hmm. I think Amelie is working on it. As soon as she has it, she will start the presentation.
Yes, so I can actually start a layout without the slides for a second. It's not so complicated. So what I'm going to do today, basically, in this is the first content webinar, right? So I'm going first to define, or let's say to give a historical background on AI. When did it start, and then give some definitions. Distinctions, taxonomy of different types of AI, and then look around in our daily lives and see how different AI applications are present. Sometimes with us, aware of that, and sometimes with us being unaware of that. So that's more or less the presentation of today. I'm going to try to give examples, and in the last couple of slides, I'm going to talk about the challenges because, as we said, AI is present almost everywhere, right? So, which means it's going to have ethical, societal, and legal, consequences. So that's more or less the story. I can start until we get the slides. I can start quickly. By just a quick question for the audience to think about it. When did you think AI and robotics, for instance, did start? Just think about this. Luckily, I think we have the slides.
We have a few responses here, and just a heads up, for the moment, you can't talk because we have too many people. But after the session ends, you will be able to have a talk. For now, please write everything in the chat.
Yes, that's actually I like the responses on the chat. But just can you please go full screen for the slides? Yes, and we can skip this slide because I already said it. Yeah, just go to the next one. Yeah, so when did AI start? I asked this question. What I wanted to say here is just that, well, AI started, as you mentioned, in the 20th century as a modern beginning, but this we are going to explain later. But before that, what we need to say is that the same way when we talk about the history of aviation, we go back to the Greeks, and we go back to ancient times where people started to try to wear some kind of jackets, mimicking birds' wings and so on. Well, in AI, it's the same. Here, I'm putting some examples. One is a Greek myth for a robot made of copper or bronze. I don't remember exactly, named Talos, and this is considered to be one of the early mythology about robots. As I said, it was a giant used to help the army, and it was made of copper. So this was more like a myth, but we also have people trying to think about it from a scientific perspective. I also attached two manuscript copies. This one is from the Middle East, from an area now around the borders between Syria, Iraq, and Turkey. There was an engineer, a mechanical engineer guy, who tried to think about developing a robot. On the left, it was a robot that gives coffee. So it's just like what we are trying to do now in a robot competition. We have robots that try to give coffee, or to give you Coca-Cola, or to help you in a kitchen. So this is on the left, and on the right up, we have a kind of an alarm robot. So when you need to wake up, this robot is supposed to sing for you, or to play music to wake you up. And this was already early 13th century. So we have lots of references about AI in history and about robots. But we, of course, lack the technology to implement it. And now, if we go to the next slide, we start talking about the modern beginnings of AI. Can you please go to the next slide? Yes. So AI has been a dream for a while, but with the advent of computers, with the advent of all the electronics and so on, we have finally the modern beginnings. And the official starting point of AI is what we call the Dartmouth Conference. So it's a place in the US, and it took place in 1954. And this is where, so these people you see in the photos are really the founding fathers of AI, including, for instance, John McCarthy and Marvin Minsky. So the big names of AI. And this is when they decided that let's call the field AI. Before, we had other names like cybernetics and other names, but in this conference, we called it AI. This was let's say, the launch of the topic. Now, of course, during the history of AI, it was not always as we witness it today, like AI receiving lots of attention and lots of money and big hype. No, in the history of AI, we distinguish between what we call winters and summers. And this is important because this gives you the context of what we are living today. So why we call it winters and summers? Because at some point in the history of AI, people are optimistic. They have hopes that AI is going to revolutionize our life, industry, and so on. But at some other, this we call it a summer, where we have lots of money, budget, and also the policymakers supporting AI. But then at some point, we also have a problem with what we call AI winters. And AI winters are when it's the opposite. When people are pessimistic about AI, when the policymaker thinks it's useless. And typically, these happens at some turning point. So I know a very famous turning point happened in the early 70s when one of the existing model at the time failed to model an XOR function. A very simple, in logics, we have and OR and XOR. XOR is very simple, but still a basic model at the time was not able to do an XOR, and this accelerated into an AI winter, and people started to lose hope. An opposite case when, as I put on the photo, a chess AI model managed to beat the world champion Garry Kasparov in 1997, and this was a very highly mediatized and was a turning point in the history of AI. So we have lots of investment and lots of as achievements. So that's to say that, again, we have winters and summers. Today, we are in the best summer of AI. We are in a prosperous situation where everyone is talking about AI. So that's the context of today. I will explain why later. Please go to the next slide. So before we proceed, let's talk a bit about so I'm just answering the chat. Salim is asking, what is an AI winter? What is an AI summer? So AI winter is when people get pessimistic about AI and no fund is invested. AI summer is when we are happy with and optimistic. We have hopes in the future of AI, and we get lots of funds. So very quickly. So now let me move. Sorry.
At the end, we will have a Q&A session where the questions are projected on screen.
Okay. Yes.
So, but if you want to do it in between, then we can have an in-between session. Just let us know. We will project the questions here on screen.
No, it's fine. It's fine. We can keep the questions today. So, thanks. So what is artificial intelligence? Let me move now to a bit of definitions. Well, a very, very simple way to define artificial intelligence is that we have a machine. In this case, it's a computer, and the goal to make the machine perform tasks that typically require intelligence the same way we do. And then, of course, at every decade, we change our definition of what is a task that requires intelligence. For now, we think of any task that requires learning, reasoning, problem solving, perception, and language understanding. We consider this as a task that needs intelligence. Okay, that's very important. Why I'm saying this is because probably 60 years ago, if we do a sorting algorithm, a sort A, B, C, D, and so on, this was considered to be somehow intelligent. Now this is not intelligence anymore. Now we consider this as a mechanic kind of thing, and we are asking for more advanced problem solving and reasoning, like what you see in ChatGPT. Okay, so I will give the different distinctions between the types of intelligence in the next slide. But before that, I want to get back to the point saying what is intelligence and how can we qualify a machine as intelligent or not. Here, more or less, we rely on Alan Turing, who in 1950, so this was already very long ago in the history of AI, even before the first conference, and Alan Turing laid out a definition of how a machine is intelligent, and this definition relies on deception. It says that if you sit with a machine, or if you chat, let's say, with a machine, and for 15 minutes you are unable to distinguish if this machine is a machine or a human because it shows some kind of intelligence, it means that this machine is intelligent. So 15 minutes you chat with a machine, and then you are unable to say if this is a machine or a human. This is the definition of Alan Turing, and is very important in the context of today because of ChatGPT and because of chatbots. Now, the definition itself is debated, is controversial, is obsolete, and so on, I know, but it's important to point it out, first for a historical perspective, and second, because of chatbots and large language models. So this is basically how people at the beginning of AI started to say, okay, how can we define intelligence? Let's move to the next slide, because then we had more debates about uh, what is artificial intelligence. Let's distinguish into different types. So, of course, let me start from up right. Uh, Artificial general intelligence, or AGI, it happened. In the beginning, researchers were dreaming about, reproducing the human intelligence in all its form and capacities, and they used to call this artificial general intelligence. I'm talking in the 50s, by the way. So, as I define it, it's an AI with human-like cognitive abilities. But due to machine limitations at the time, due to the chip limitations and many technical details, of course, it was not possible to have artificial general intelligence in that early days. But still, researchers were very optimistic and ambitious, maybe too much. And this actually is one of the reasons of the AI winter that followed. Okay, so what happened is people shifted to what we call narrow artificial intelligence, or artificial narrow intelligence. In this case, we say, let's not create an AI that is as capable as a human being. Let's just focus on one thing. And this one thing you can imagine, whatever you want. You can think of Google if you want. You can think of any special system that is specialized in one very limited scope of application. So, for instance, a recommender system like the one you have on Netflix or Siri, or any kind of very specific AI you use for one particular task. This is, for instance, is artificial narrow intelligence. Now, since we are now again very optimistic, now people are talking about that we are approaching the artificial general intelligence. Of course, this is all debated, but researchers are pointing out to artificial super intelligence. So this is a different type of intelligence where the AI becomes even more performing than a human, and it becomes some sort of a super mind that is capable of exceeding our intelligence. And why? First, because the computational power at its disposal, at its service, exceeds our computational, our brain. And second, and this is even more important, as even if a human is hardworking and so on, it will not have all the data available to such an artificial super intelligence, because this artificial super intelligence is actually connected to the web, is actually connected to sensor networks, so it can measure, for instance, the temperature everywhere on Earth in real time and so on. So a human will never be able to do such a thing, which means it's going to exceed us. So where are we today? Yes, this is a big debate. We think that we are in, of course, we think that we achieved artificial narrow intelligence. This is already the case in many applications. For the artificial general intelligence, it starts to be controversial. I can discuss it later. And for the artificial super intelligence is even more controversial. If you want, we can keep it for the discussion later. The only thing I want to stress here is that we have this layered approach. And when you say AI, it doesn't mean, how to say, it doesn't mean that we are meaning something like an AI that is replacing the human in all its cognitive capacities, except if you say artificial general intelligence. Okay, so that's more or less the story here. We can just go to the discussion in the Q&A session. But now I want to move to the next slide, please. Yes. So now I want to talk about the hype. So clearly, especially since 2-3 years, we have a very strong hype of AI. I put some examples on the up left. This is an NVIDIA application. You know, NVIDIA, the one that does the company that does the chips for the video games and for the GPU in general. So up left, all these people that you see up left are not real people. They are artificially generated. Their faces look so real that you deceive the end user. You will never be able, unless there's some error in the picture, you will never be able to know that this is not a real person. And this is astonishing, very astonishing. Why? It's because we humans, we spend our time since we are newborns to look at faces and distinguish faces and distinguish facial expressions and so on and so on. And still, with this capacity where we are very strong at, we are unable to distinguish an artificial face. And this is a technology. You know, you have a website called This Face Doesn't Exist. Yes, so for Jean, don't worry about the number of slides. I have many extra slides that I'm not going to present except for the Q&A. So no worries. So this is uplift. Now, for the down right, this is a video game graphics that is designed by AI. So now it means that you don't need to design. You don't need a designer to do a video game graphics for you. You can do it with an AI. So it's already amazing. I also pasted 2 videos from the OpenAI Institute promotion of the new GPT. You can look at it. One example is doing translation from Italian to English. The one down is doing, so the guy is talking to the ChatGPT to prepare an interview, a job interview he has, which shows that you can now use the AI for such an interactive task. It will listen to your intonation. It will tell you improve this, improve that. So that's what we can do now with models like generative AI. And I'm going to try to explain you a bit how it works. So please move to the next slide. Yes. So how it works? As I will tell you later, AI is split into 2 big branches. So the branch that is working marvelously now, yes, exactly, it is the one with, it's called neural networks. And why do we call it like this? Basically, they used to call it artificial neurons. So in 1941, so we were still in the World War II, there was a scientist who tried to mimic or to model a neuron on a machine. And, you know, a neuron is the one that I have in the photo. And he managed to show that he can do this Hebbian learning, you know, the synaptic learning between neurons, and he can show that he can solve very basic applications. So this was already more than 80 years ago, and then people started to develop these neural networks and make them more sophisticated, and they are now able to do very complex tasks. I'm going to explain later, but this is what I want you to know is one of the branches of AI now relies on neural network. It's just kind of artificial neurons based on this paper in 1941, but making it more and more and more and more complex. So in the beginning, in 1941, it was 1 neuron. Now you have millions. And these neurons are very strong in capturing information and perceiving the environment. And that's how it works. Okay, please move to the next slide. So I'm giving here an example of a neural network. It's a very, as I said, neural networks are very strong in perception. So I have here a very simple example. It's about classification. Okay, classification. So the idea here is you have this neural network. We call it CNN, convolutional neural network. and then you train it on images of dogs and cats, and then the synaptic weights or the synaptic learning is changed for this. Now the neural network after the training is tuned to be able to distinguish cats and dogs. And then whenever you give the photo of a cat to the neural network outside the training, by the way, so outside the training you tell the neural network, is it a cat or a dog? And then it can tell you, well, this is a cat, this is a dog, this is a cat, this is a dog. And it means that it now is able to classify. Of course, you can generalize this example, and you can start giving it complex photos, not only of the dogs and cats. It can also include music instruments. It can include a player. It can include buildings, bridges, whatever. And then you have a computer vision application. Okay, for instance, suppose that you are trying to, you are having a computer recognizing an image at the airport. You know, this is type of systems that are able, I don't know, to identify, you know, how illegal items. You can also train a system like this. So that's how this model works. Please go to the next slide. So this was the first type of AI. Now, the second type of AI is also dates back from the 50s, but if you go to its roots, well, it comes from Aristotle. This one doesn't rely on this weird synaptic learning that you cannot make sense of. Instead, this one relies on rules. And that's why we call it symbolic AI or rule-based AI. So this one relies mainly on reasoning. So it uses clear rules to make decisions, just like a recipe, you know. And it relies on logic like deduction. So a very simple example that comes from Socrates. It says, for instance, Luxembourg is in Europe, Belval is in Luxembourg, which means we deduce that Belval is in Europe. It's this way that this kind of AI work, but of course you need to imagine a system with a rule base of very, very big fact bases and rules in thousands or hundreds of thousands. This was very dominant and useful in the 70s. I think in the next slide I'm going to explain it more. Can you please go to the next slide? No. So it's not the. So this was the two branches of AI. You need to know that these two branches are not often working together. Let's put it that way. And you have different teams with different backgrounds in each branch. Okay. So now let's take some examples before we go more into theory. Let's go more into examples on what do you find AI in your everyday life. So you know, virtual assistant, you have Siri, Alexa, you have the Google Assistant, you have everything on your phone. You have chatbots. You have the difference between a chatbot and GPT is that chatbot is tuned for a limited set of questions and answers. You know, for instance, like the chatbot that you ask when you are talking to the train station, to the train rail lines, is very simple. But on the other hand, the AI-powered assistant like GPT is much more complex. You have also AI used in education, many adaptive learning platforms. I'm going to give more examples. You have AI in healthcare, of course. You have many different applications in healthcare, like AI-powered diagnostics, drug discovery. People are developing drugs based on AI. You even have AI, for instance, for tasks that are related to health, but not directly. Like, for instance, you have an AI system that tells you who should get the next liver transplant. You have also AI system that is used for HR. So I need to hire a CEO, and then I rely on AI to sort the CVs, to find the best matches, and so on. And that's where we have a very important ethical reflection point, which is what should we do about this? Because now we are delegating very important stuff to AI, and how will this delegation? We are no longer taking the decisions by ourselves. How will this influence the decision making? A very naive way to answer this question is a shallow one by saying, well, AI is a machine, and it means it's objective and is neutral and is going to, to solve the problem, in an objective way, scientific way, not biased. But this is obviously wrong. We even have examples from the 70s, from the 80s, 90s. AI systems were used for HR in hospitals, and for instance, we discovered that they are discriminating systematically against women, for instance. So we will talk about this later. But now let's move to the next slide. Yes. So one thing before, again, developing more about theoretical AI, I want to talk about GPT and how do they work. So and also the distinction between them and chatbots. So virtual assistant like GPT are much more complex. They are relying on a field of AI. We call it NLP, natural language processing. It understands your commands in natural language, so you can write it anyway, even in any language, right? You can ask GPT in French, English, German, Hindi, Arabic, and it can still answer you, and you can mix different languages with it. It also understands even programming language and so on. Yes. So it's a very strong one. This we call it virtual assistant. On the other hand, we have chatbot. It has some AI, but it's all pre-programmed, and is not linked to the when it answers you. It's not linked to the web. Still, it's used for customer support and education a bit. Now, as a homework, you can go and try 3-4 types of AI systems and chatbots. For instance, I know if you go to Tango or if you go to any communication provider, they have chatbots, and you can see that it only offers limited functionality. On the other hand, you can test different GPTs or LLMs, large language models. For instance, you can test GPT, you can test Gemini, you can test the new Chinese DeepSeek, and so on. You just consider this as a homework, and let's move to the next slide, please. Yes. Now, I want to give you an example of what AI can do in one domain, such as education. So, typically in teaching, in a classic setting, you have one teacher, you have, I don't know, maybe 20 students. And so this means that the teacher cannot really personalize the pace and the focus of the course to each student, because there's only one teacher, and it's the content of the lecture is broadcast to everyone, like what I'm doing to you now. I'm just giving one version of the slides. I cannot know what are really in your mind questions about the topic and give you the corresponding answers. Well, we think with AI we can do that. We can do what we call a personalized learning, where AI adapts to your progress, adapts to the questions you are raising in your mind. Of course, you need to explicitly say them. Adapt to your level. For instance, if I'm explaining mathematics, to a kid, and then I see that, well, he has a weak point in trigonometry, I can focus on that instead of on just skipping it to the next level and creating this kind of gaps. Same that goes for language. So you can already see this in applications like Duolingo, where language learning is personalized to your progress. The second type is automated grading. So instead of the teacher grading paper by paper, I used to do this in the university. Sometimes I used to have maybe 200 or 300 copies of the exam answers. Now AI can help me. You can also use AI to generate educational material and so on. But of course, this again has this critical thinking, ethical question. Well, will AI be able to create better learning material than the human teachers? Well, this is a question that we can discuss in the this question and answer session. But of course, there's no obvious answer to it. Please move to the next slide. Yes. And this is one of the last slide on this section. Here I'm going to try to debunk some of the myth about AI. AI will replace all jobs. Well, we don't think so, because until now, as you can see, AI is still limited to in many aspects. So for now, we think that AI is a driver for growth and not for unemployment. And if you look at the economists' perspectives or projections, we think that the next growth cycle could be actually powered by AI. Now, AI can think like humans. Well, this is also very problematic and very philosophical questions. Most of the scientists will tell you, no, it cannot, because it doesn't have common sense and it lacks emotions, which are both very important for the intelligence. AI myth number 3: AI is always correct. Obviously not. You can just try to make GPT hallucinate, and it will make lots of hallucinations. That's number 1. Number 2: many of AI systems are tightly dependent on the data they are trained on. I will explain to you later. And this means we have lots of biases, as we explained before. So please move to the next slide. I think I already covered these, so I prefer to go to the more theoretical. Yes. So here I listed some of the developments. You can see also how AI is now being used in medicine, drug discovery, and so on. You can look at it and ask me if you have any questions. Please move again to the next slide. Yes. This is a very important slide. So let me start with a picture below. So the picture below, both are brides. So this is both coming from the, from the celebration of a marriage. But the AI at the time, this I got it from Nature, by the way, the magazine Nature. AI, the best model at the time, did not manage to classify. I told you AI is very strong in classification, right? But even though it did not succeed in classifying the right picture to as a bride, it did with only the left one, so the white American bride. With the right one, it didn't. Why? Because it considered it to be ethnic performance. In reality, it's not ethnic performance. In reality, is a marriage celebration in North India. But AI cannot do that. And the reason is very simple. It's because if you go to the most of the picture data set available online, most of them mainly are representing Western and European North American culture and not, what we call the global South. So it means that our biases that we have on the data can come again in the AI. Another example is in USA, at some point in time, they used AI to decide where to patrol in the police patrolling. And what happened is AI recommended in a very biased way to send the patrols to the minority neighborhood, which means the African American neighborhood. And why? It's because of the data set available at the time. This data set showed that most of the law infraction happens from this neighborhood, and then consequently it recommended the patrolling to take place in the same neighborhood, which means it's a vicious circle, because you patrol in the same neighborhood and then you end up discovering infractions, and then you end up actually reinforcing the belief that you have, and so on and so on and so on. So this shows that it could be very dangerous, and we need to be very much careful both on the training data and on the algorithm we used, but the training data is the key. Okay, we have also other obvious problems, like for instance privacy concerns with the where is my data hosted. For instance, if I use DeepSeek, my data is going to be hosted in China. If I use GPT, I think it's going to be hosted in the US. So this is also a sensitive issue. We have also the question of creativity. Can AI create original content or is not? So all of these kind of questions now are being answered by or investigated by the research community. And we consider them to be, we call them ethical, social, and legal implications of AI. Very hot topic. Please move forward. Yes. So this is like a conclusion slide. AI is really transforming industries from education to healthcare. Everything you can imagine, we think that AI is going to immerse into that, but AI is also facing lots of ethical considerations that are crucial in AI development. And now, which means that, as I will show in the next slide, it means two points. One is that now we are no longer talking about AI proper. We are qualifying it with something. So we have personalized AI, we have ethical AI, and we have things like, for instance, explainable AI, trustworthy AI, and so on. And the last thought, this is very relevant for you as an audience, is AI is, because of all of this, is becoming more and more interdisciplinary, which means that even researchers and practitioners from different backgrounds are going to engage with it. So you, from your own position, you need to think what would be your contribution with this wave, because now AI is not an exclusive affair of AI researchers and computer scientists. And that's the main, the end of my main slides. I just have a couple of minutes to show you one example of these recent trends in AI. Can you please move to the next slide? Yes. So, very quickly, here you have another data set of images. You have half of them are of Chihuahuas, a type of small dog, and another half are of muffins. But the muffins, they have blackberries. And we ended up having models of AI that are unable to distinguish between Chihuahua and a dog. Between Chihuahua and a muffin. And the reason is why. This why question is now becoming very, very important in AI. And that's why we have lots of researchers who are working on explainable AI. In a sense, we don't only need a question, an answer that this is a dog. I think, as an AI, I think this is a dog or a chihuahua or a muffin. I need to know why why the AI classified it as such. And this we call explainable AI. Please move to the next slide. So this explainable AI trend is not new, but it's now getting so much attention for for several reasons. In the next slide, I'm going to say what it is, and that will be my final slide. It is because of what we are doing now. I talked to you about the neural network, right? And I told you about the artificial neuron. Now, what we are witnessing since 20 years ago until now is that with the advent of GPU and NVIDIA, we can now calculate very complex models. And that's what we call deep learning. And this deep learning is when we concatenate these layers of a neural network, and we have layers and layers and layers and layers of neural network, and we make it more performing and stronger in calculating things like image classification, and that's what is deep learning. But on the other hand, the learning is happening in the connection on the edges between the nodes, and we are unable to know why a connection fired and why not, why a classification decision was made and why not. So existing AI is now opaque. This is very problematic for lots of reasons. We don't know why this patient is going to have a liver transplant or why not, which means it's not transparent. And that's why recently, let's say in the last 5 to 10 years, we are moving to this explainable AI as a trend. And this is not only the only trend in AI. We have, as I said, explainable AI, trustworthy AI, fair AI, and so on. This is the scale, I mean, let's say the timeline between in the coming 5 to 10 years of this responsible AI, trustworthy AI, and so on. I hope with this example, I showed you especially with this deep learning slide, I showed you the current challenge of these methods. They are sub-symbolic, numerical. They succeed in giving an answer, but we don't know how and why. And that's what we are investigating right now. And thank you.
All right, thank you so much for the presentation and these very interesting and intriguing questions you provoked here in the chat. We have maybe a few minutes, maybe 5 minutes before many people must go. So let me jump right in it, shall we? So the questions are starting from the beginning when they were asked. So what is AI winter and summer? Just quickly, if you want to repeat.
Yeah, I already answered this question. So it's very simple. AI winter when we don't have hopes, we don't have money in AI. AI summer is the opposite, when we think that AI is going to make a revolution. I mean, in the positive sense.
From David, where do we stand today? Is AI today AGI?
It's approaching AGI. In my opinion, not yet, but it's approaching it. But this is a very, very debatable, controversial question. On the one extremity, you have people saying that GPT itself is not intelligent at all and is statistical parrot. On the other hand, you have people saying that with GPT, we finally achieved the artificial general intelligence. So it's a scholar debate.
Mm-hmm. Then artificial superintelligence implies self-awareness by Arno.
I think doesn't need to be the artificial superintelligence in the agent community. So this is a subdivision of AI where you have autonomous software systems that are autonomous and that are sociable. So they work with each other and they perceive their environment. They are goal-driven. This has been there for 35 years. I actually did my PhD in that. And in there, we have mechanisms for self-awareness. And so it doesn't need artificial super intelligence You have it in even artificial local intelligence. You have this. But the other way around, I think, yes, of course, if you have artificial super intelligence, it implies self-awareness. But what I'm trying to explain is that self-awareness is not defined to be that demanding. It's even less.
It's not the ultimate measurement of the.
No.
Yeah.
And if
So
you are interested
another-
in this, I can send you a paper of a scientist telling you, explaining exactly what is self-awareness in agents. This is already from 2010.
You should, and we will post it in the forum as well. Please, everything you can have. It will maybe fire a debate. Where
Yes,
where do
happy to do so.
we? Yes. So where do
So
DeepSeek model
I have
fit?
an opinion about DeepSeek. So DeepSeek is marvelous in efficiency, but not in AI strength. So it means that with a very limited set of resources, it can reach, let's say, up to 80% of GPT. But still, GPT is better in reasoning capacities. So DeepSeek is not the most advanced model. If you go to the out there to the web and to the even to the literature that is starting to comment DeepSeek, you will see that its powerful point is not in the reasoning capacity it brings to the table. No, it's in its efficiency. So it can how to say, it's like with a very small car, which is DeepSeek here, you can pull 10 tons, but it's not the same contribution of GPT. GPT is like a tractor that can pull big things but consumes lots of energy and investment. I hope I made the distinction clear. So to answer the question, I think all the LLMs, including DeepSeek, are actually approaching AGI, but in this conversational context, not AGI in the general context, because us humans, we excel in everything at once. Like we talk, we understand language, we can move. So we have also this kinetic capacities. We have emotional intelligence. So all these LLMs are approaching AGI, but in conversational settings, not in everywhere.
So the other one relates to that by Sam. It's the question whether is an AGI smart enough to improve itself, and does that lead to super intelligence, or does that lead somewhere else, maybe to another route?
I think it can. I think it can. And this artificial super intelligence, again, if we restricted in one domain, like for instance, conversational or smart city and so on, it can be done because we have the big data paradigm that is there and that is ready to be integrated with a distributed and let's say omnipresent AI. So this is not a big shift, and I think it can be done.
There's another question here on feasibility, basically. It was when you were talking about the creation of the video games. How much effort do you think it goes into designing such a thing, and is it worth it to use this method over traditional graphics design and visualization at the moment?
No. So it's again, it's also a trade-off. So if you know these games like for instance, Don't Starve or Don't Starve with Me, they already have I think they call it bionemes, like type of environments in the game that are automatically generated. So it's again a trade-off in a sense. Of course, you still need the designer. Some of the tedious part of the design could be taken away by the AI, but you still need the designer. Actually, I think the AI will be a must in cases where you have infinite, environment, infinite world for the game. But of course, it's the designer who's steering the everything.
I would like to go deeper into that, but let's stick with the questions. Could neural networks be considered a branch of machine learning, and did they originate from perception?
Of course.
Marcio.
Of course, actually, neural network is the most successful branch of machine learning. Machine learning is could be considered also as branches of two things. One is logic and reasoning, as I mentioned of Aristotle and this kind of things. The other one is statistics. That's basically the idea. But yes, of course, neural network is a branch of machine learning. Did they originated from perceptrons? I think so. Yes.
Sorry. I was already to the next one.
No, it's good. I can go answer the next one.
About the Ethics Act, there was a little discussion here. What do you think? How much of the EU AI Act do we need?
I think we need it, and I've been in contact with different type of stakeholders like researchers and also industry pioneers and so on. And even the industry pioneers are asking for regulation because they are kind of I don't want to say afraid, but they create something. It's very useful, but it also can have some downside effects, and they are unsure about it at the moment. And it's only the lawmaker who can foresee in the future, the different consequences. So I think EU is doing very well in that. Many people are asking for more, even the practitioners. I know that it's a bit not straightforward, but it's like that. Yes, and the last thing I want to mention about this regulation, the only problem with EU is that it always gives the priority to regulation and less to to actual development of AI, and that's why you find the groundbreaking models always coming from China or to US, and then EU is trying to regulate. It's good to regulate, but you also need to innovate as much as the others.
Absolutely. There has been a confusion about chatbots, and I think this question sums it up. So when they are connected to the internet, to the web, but I think there's a confusion here. Does that mean that they are enriching themselves and they're training themselves in the process of being connected, or does this mean that can you clear this up a little?
Actually, there are three layers to distinguish. So first, we have the chatbot, the good old chatbot. This one could be even procedural in a sense. It's all pre-programmed. It expect a predefined set of questions and interaction. For instance, if you go to a chatbot of an internet provider or trains, you cannot even type. You have to choose sometimes what do you want to do, right? Whatever you type, it will not take your input. It will instead ask you to choose. I want, for instance, to book a ticket. So that's the mentality of a classic chatbot. So this is layer one. Layer two is what we call an LLM, large language model, better known as GPT. GPT is an example of that. This is not about predefined things. This is more about it has access to lots of data from the internet, and it has been trained to understand text and to generate text. But classic LLM is not necessarily connected online. It has been trained on a closed data set at some point in time. It's, for instance, when they first released GPT, the GPT used to tell you, I don't know anything beyond 2022. Because it was not connected. So this is layer two. Layer three is when you also manage to connect online data with the with the data available to the LLM GPT, and make it give you also online answers.
All right.
I hope I answered this.
Yeah, I understood, but we are out of time either way. There's one more interesting question. Oh, the question was: are there more examples of AI being used for social cause rather than for the corporate giants increasing their sales? Do you know of such examples, maybe?
Let me see. So you want AI for
social causes,
social good.
examples for that. That's what he was referring to.
I think. Well, I'm sure you have lots of things like this, but unfortunately, they don't get as much advertisement as the others. You can have systems that try, I don't know, to optimize for the environmental consumption, CO2 emissions, and so on. You have also. I remember when I was in Sweden, there used to be an app that gives you and also for free non-profit, that gives you the CO2 footprint of any product at a supermarket and this kind of things. So or the water footprint, the water consumption, how many liters, and so on. I know that it exists, but unfortunately they are less commercialized and less advertised, let's say, than the bigger ones.
Mm-hmm. Maybe you can post these examples as well if you know some, and we will post them in the forum.
Yes.
There's one more question, but we don't have time anymore. How can we be sure that general AI will not be biased from its own as its core in the algorithm that was integrated during its conception? So when do you consider that the changes you apply can themselves be limitations for the general AI?
Well, no, I don't think so. I don't think that the changes you apply can limit the general AI. But to answer the first part of the question, it's all about data. I mean, even us, we are biased, right? Because we have imperfect and limited access to data. It has been known. I mean, for us humans, how do we deal with our own biases? As a personal, on the personal level, well, by reading more and by getting more knowledge and training in getting de-biased on the one person's, level. But on the group or society level, we try to mitigate biases by talking about them and by decentralizing the solution. So, for instance, instead of having one politician, we have a council, right? So if we have one bias, two bias, by having more, decentralized decision-making structure and by representing different people, we try to mitigate the biases we have in our society. Of course, I don't think we are going to reach 0% bias-free AI because we don't have a bias-free human society. So yet, at least. So yeah.
So do you think that general AI will be a collective of differently trained models of AIs that are constantly maybe being switched?
This is exactly. So this is already being investigated and works. In least we have one team working on that, and globally, this is the AI agent paradigm. For instance, Microsoft is investigating this. So instead of having one LLM, so one GPT, you have a group of LLMs, each handling one task or one perspective, and so on. So that's according to researchers, this is one of the next big waves. Is not having one component like GPT, it's having a decentralized network of artificial intelligence.
Sounds fascinating. So we are over time already. We have to stop the session, the official session, the recording. Thank you again, Dr. Najat Amro, for the presentation and for being available for the questions here. And I will stop the recording now.
Thank you, and it really was a pleasure.
Yes.